Now I'm going to show you how you can use K-mean clustering on one of the dataset. That would be salary dataset. K-mean clustering is a part of unsupervised machine learning. So the first thing I'm going to be doing is importing my pandas SPD. This is the library I'll be using to read the CSV file. So this is the CSV file that I have, and I'm printing out few sample. In this case, I'm printing out the 5 sample. I just want to see what's inside the file. So this contains name of somebody, what their age is, and what their salary is. Let's look at the shape. I want to know how many rows and columns I have. In this case, there are 22 rows and 3 columns. You can see that right there, 3 columns. Column 1, 2, 3. Okay, let's plot this salary versus the age. I want to see how it looks like. So in this case, you can see that this is your salary, y-axis would be your salary, and your x-axis, that would be age. And by looking at this, you can see that there are approximately 3 clusters. Seems like 3 clusters. This would be your cluster 1, right here, this would be a cluster 2, and that would be your cluster 3. So let's see if our algorithm, if your k-mean is able to find these 3 clusters. Now, when you use k-means, you want to make sure that you scale your feature. This is one of the very important steps. And that's because in your k-mean algorithm, it's using the concept of distance. It is trying to find centroid, it's trying to find which points are closest to each other. So there's a concept of distance metric involved over here. So you do not want one column or one feature hijack the other feature. If you look over here in this particular instance, you have age and you have salary. And your salary, look at them, the big numbers. Salary are using some big numbers. Age are like kind of like small numbers. So your salary is going to hijack, it's going to dominate your age feature. You don't want that to happen. So you scale it down. You basically put them all in the same scale. Okay, so in this case, I'm calling min-max scalar and creating a scalar instance and then scaling my age. And so let's see, I scaled age and I also scaled my salary. Now let's look at some of the few values. I want to see how my scale data now looks like. So in this case, you can see your age. Now you can see your age is all basically scaled value, scaled down. Same thing with your salary. Salary is all scaled down. And now let's use k-means on our data set. First thing I'm doing, I'm importing my k-means. I'm specifying number of clusters. In this case, I'm just picking up 3 clusters because I saw 3 clusters. I'll show you later on how to find the number of clusters. So I put number of clusters as 3 right now, and I'm giving it the data right here, my age and salary, and run it. It gets trained, and then it finds the cluster. So in this case, I'm accessing the cluster variable. So the way you access the clusters is there's an inbuilt label right here. This is going to print out the clusters for you, and also you can find the centroid. This one is going to give you the centroid. So when I run this, I print out my clusters and also print out my centroid, and these gives me the cluster for each one of these points, and also the centroid. There are 3 centroids right here because there were 3 clusters. So in this case, the first point is assigned cluster 0, the second point is assigned cluster 0, and so on and so forth. What I'm going to do is I'm going to put these clusters next to the column. So this way I can see that. So in my data frame, I'm creating another column called clusters, and I'm giving it the value clusters right here. And I print my data frame. This way I can view my points and also my clusters. So name, Sunny, his age is this is the scaled value, and the salary is this, and the cluster is 0. Nancy, this is the record, this is assigned cluster 0. Okay, so you can see all the clusters now. Now let's plot the point and the centroid. So in this instance, I'm filtering my data frame. I'm actually putting up all my cluster 0 in one data frame. I'm calling it df1. And then I'm filtering my data frame with cluster 1. Right here, that's going to go into df2. And likewise, df3, that will contain the third cluster. So this way, I'm plotting all my points. In this case, first I'm plotting my cluster 1, and I'm also plotting cluster 2 and cluster 3. And I'm also plotting centroid for each one of them. So when I run this, it's going to give me the diagram. There you go. This is the plot right here. Let me decrease the size of screen so it's a little bit more viewable. There you go. And let me increase the size. All right. So now you can see that these are your points, and it identified 3 clusters. So this was the cluster, one of the cluster, this is the second cluster, and this is the third cluster right here. And these star points right here, these are your centroid. So it's able to identify the centroid, and also it did a pretty good job. It was able to find the centroid, and also it was able to label the points correctly. All right, let me increase the size of the screen now. Okay. Now I'm going to show you elbow method. Like, how do you find the optimal number of clusters? In the beginning, I've chosen k equal to 3 because I already knew visually that there's going to be 3 clusters. But in real life, you're not going to know that. So you use something called elbow method. The first thing you do is you actually run this model multiple time on different k's. So that's what I'm doing. I'm picking up different values of k. So I'm picking up from 1 to 10. So I'm iterating through each one of the 10, and I'm calculating its WCSS, which stands for within cluster sum of squares. Basically, it measures how much error there is in your data. So you want, in this case, I'm measuring each one of these values, and then I get the answer right here. So then I plot these values, and by plotting them this way, I can tell which is the good number of clusters. So in this case, when I plot it, and let me make this thing a little bit down, bring it down. There you go. So you want to look for the elbow. So in this case, when your k was equal to 1, which is right here, your WCSS was this value, which is a big value. So when your K becomes 2, which is right here, your WCSS drops. When your K is 3, your WCSS drops, and then it keeps dropping. But it seems like at this point right here, the drop is small. Up to this point, the drop was big, and this is like an elbow. So this is called an elbow. So this K equal to 3, I would say, is a good point or good number of clusters. So we should stick with K equal to 3.